Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem today. Something called conservation of energy. We've been talking about energy. We've learned about essentially the concept really we've been focusing on is mechanical energy, which takes several forms, right? You've got kinetic energy, you've got potential energy, and in potential energy, you have the potential energy of gravity, you have the potential energy of spring, you've got kinetic energy, which is 1/2 mv squared. We can have other potential energies. We can have potential energy of rolling resistance and all these different kinds of energies that we can look at. And one of the big ideas in all of science, frankly, is this concept called conservation. It's called the law of conservation of energy, and it says that energy cannot be created or destroyed. It can only be transformed. Or to put it another way, the amount of energy in has to equal the amount of energy out. Now also energy can get converted to, very common, into thermal energy, right? So all of the energy that goes into a system has to come out in various and sundry forms. But actually, this makes solving energy problems super easy because you have to do some accounting. And the accounting means it has to completely add up to like the same number. So let's take as an example, we've got like a ramp and we've got a spring right here, and it's at some height. We'll call this H1, and then let's just second, let's call this H2. That's a 1. And let's talk about our energy. At the beginning, when the block of wood, this is a block of wood, let's say a frictionless like ramp or whatever, the only energy it has, because we've compressed the spring, is going to be the U spring. If you recall, that's 1/2 kx squared, where x is the compression of the spring and k is the spring constant. So that's all of the energy of the system here. But once you spring the spring, so to speak, and let's say that the block of wood now is halfway on the height, it has no more spring energy. What does it have? It's got kinetic energy, which of course is 1/2 mv squared, but it's also got mgh2. Actually, I'm backwards. It's got spring here, and it's also got gravitational potential energy, be mgh1. So the mass of the object times g times h1. And then when it's down here at this spot, the only thing it has left is lost all of its energy, all of its potential energy. It only has kinetic energy, and that's 1/2 mv squared. So I can figure out the amount of energy in each system at any given moment based upon these equations. But all of these numbers have to add up to the same number. So if this is 30 joules, then this has to be 30 joules, and this equation has to add up to 30 joules. So you can figure out the total energy. They all have to add together. And so what oftentimes you're going to do when you're doing these types of problems is you're going to like set them equal to each other, okay? And so if I knew what the spring constant was, and let's say I wanted to find out what's the final velocity right here, okay? So if I knew what the mass of the object was, and I knew what the spring constant was, and how much I compressed the spring, I can find the total energy. Let's say this equals up to 100 joules. Then I would set that over here. 100 joules equals 1/2 times m, probably the mass of the block of wood, times the v. You could solve for the final velocity because they all have to add up to the same number. So I can ask you for any variable because you're going to be able to know that this box equals this situation, and you can solve these problems. It's all about setting them equal to each other. You're going to very often see something like mgh equals 1/2 mv squared. So if I didn't have a spring and it was falling, maybe it was at this stage right here, and it was falling, and I want to find the final velocity. This didn't have a spring situation. I could just solve for the velocity. It turns out, oftentimes you'll see the masses will cancel, and it's gh equals 1/2 v squared, solve for v. These are the kind of problems you're going to see when you do the homework tonight, and also when you do the questions in class. Hey guys, I don't think you got a problem. Houston, we don't have a problem. We'll see you in class.